Physics Penguin.
Hello and welcome to Physics Penguins. Ah! Phew, that was close. That car came out of nowhere. Let's try that again. Welcome to Physics Penguin's Guide to Stopping a Car. This week we're going to look at two basic things that affect how long a car travels while trying to stop. We're then going to look at how to measure a driver's reaction time, and then next week we'll put all this together and learn some useful things about road safety and causes of accidents. This has been a scary start already. It's really odd that people often worry about gun and knife crime and how it affects young people, but in the UK we don't seem as concerned about road accidents. In the UK we have about 800 murders of all sorts in a year, but compare that to the death toll on the roads. Over 150,000 people a year are hurt and nearly 2,000 die each year. We're going to see why the roads can be so dangerous. Very often we blame drivers for accidents. Sadly, this is often correct. When you take control of a vehicle, you are responsible for what it does. If you understand what can make a situation dangerous, then you should adjust your driving to reflect that. Let's talk about driver reactions. How quick are your reactions? Are you better than average? How could you even measure such a thing? Well, there are many ways to measure reactions, but a really simple one is to team up and get a friend to hold a meter ruler so that the end of it is just above your open hand with the hand open. Without warning, your friend can release the ruler. The less of the ruler that gets through your fingers, the quicker your reactions. The problem with this is that you are measuring time with a distance, and that's kind of weird. So you could try and calibrate the scale. This means to replace the centimetre marks with, say, 1/10 of a second. But that would mean filming the ruler falling in slow motion and then painting on new marks every 1/10 of a second. Because the ruler will speed up, then reach a steady speed, the marks won't even be evenly spread. If you've tried stopping and starting a stopwatch, you might think you've got great reactions. So why does reaction time even matter? If you're travelling at 30 miles an hour in good conditions, in the time you take to react to emergency, your car travels about 9 metres. We call this thinking distance, and 9 metres doesn't sound too bad, eh? Well, the problem is, the faster you go, the further your thinking distance will be. So by the time you hit 70 miles an hour, your thinking distance is 21 metres. In those 21 metres, if there is something in front of you, you will hit it before you even start to slow down. Okay, so thinking distance is important, but it's still only half of the story. Once you've actually hit the brake, the car starts to slow down. But it takes time to reach a halt. The distance the car travels while braking or slowing down is called the braking distance. It's not original, but it is good. If you go faster, the braking distance gets very large because you have to brake for longer and you were travelling faster while you braked. At 30 miles an hour, the braking distance in great conditions will be 14 metres. But by the time you reach 70 miles an hour, it takes about 75 metres at least to reduce your speed to 0. The total of thinking and braking distance is called stopping distance. These you need to know for driving a car, but not for GCSE science. However, just compare the totals for 30 and 70 miles per hour. Stopping distance is thinking distance plus braking distance. So at 30 miles an hour, that's 9 metres plus 14 metres, which is 23 metres. This is about a quarter of a sprint track. If you step into the road between parked cars at less than that distance, expect to be hit. At 70 miles per hour, the distances are 21 metres plus 75 metres for the braking distance. That's 96 metres worth of stopping distance, basically an entire sprint track. Pedestrians are not even allowed on roads with this speed limit, as they would be far too easily hurt. Please remember that these numbers are for the best driver and the best car in perfect driving conditions. Darkness, rain and ice could make the stopping distances far, far bigger. Well, that is all a bit worrying. This is why there are rules for drivers and pedestrians. A car is a heavy object travelling pretty fast. If we all take responsibility for our actions, then they can be safe, but sadly sometimes the person making the mistake isn't the person who suffers. Let's have a go at a few questions about reaction times and stopping a car. Pause the video now and give it a go. Welcome back. I hope you managed that. Let's check the answers. Question 1. What's thinking, braking and stopping distance? Well, that's pretty easy. Thinking distance is the distance, not the time. Watch out for that. A car travels while the driver reacts to a need to stop. This means the distance is affected by things that can make a driver slower to react. More of this next week. The braking distance is the distance the car travels while slowing down. It is affected by things that make braking easier or hard, like say an icy road. The stopping distance is the thinking distance plus the braking distance. Okay? Question 2. The reaction experiment was basically dropping a ruler and seeing how much falls before your subject stops it. The better the reactions, the less will have fallen. If you decided you wanted a number, you'd have to calibrate the ruler to give you time markings instead of distance. Question 3. The graph question. Well, the graph shows someone slowing down. But what is the reaction time? Well, while the driver reacts, the car doesn't change speed. He hasn't touched the brake yet. So how long does it take for the speed to start to change? According to the graph, that's 8 of those little squares, or 0.8 of a second. That's not bad. By the way, if you told somebody you were doing a reaction experiment, why is it a good idea to do a few repeat readings? Well, people will sometimes anticipate you dropping the ruler, and other times the ruler slips from their grip a bit. So you need an average of a few attempts to be sure you've got a decent whole picture. Well, that's about it once again for Physics Penguin. Stay safe on those roads. I'll see you next week, but it's ta-ta for now.